The normal distribution. A density curve that is symmetric, single-peaked, and bell-shaped is called a normal distribution. The normal distribution with mean mu and standard deviation sigma is represented by an n with the mean first, then the standard deviation. The empirical rule states if a distribution has a normal distribution, approximately 68% of all observations fall within one standard deviation of the mean. Approximately 95% of all observations fall within 2 standard deviations of the mean. And approximately 99.7% of all observations fall within 3 standard deviations of the mean. So our normal distributions will look like this, according to the empirical rule. Let's look at an example. The length of time needed to complete a certain test is normally distributed with a mean of 60 minutes and a standard deviation of 10 minutes. Here is our normal distribution. It's centered around the mean. I'm going to count by standard deviations to the right. I'm going to add 10, add another 10, and add another 10. Going the other direction, I subtract from the mean. Now we can use our empirical rule if we have values that fall within 1, 2, or 3 standard deviations from the mean. What is the probability that someone will take between 40 and 80 minutes to complete the test? Well, we're within 2 standard deviations of the mean. According to the empirical rule, that would encompass 95%. The interval that contains the middle 68% of completion times would be within 1 standard deviation of the mean. So we would go from 50 to 70. What percent of people would take more than 80 minutes to complete the test? More than 80 minutes would be the tail shaded right here. Well, between 40 and 80, we said that this was 95%. That leaves 5% total for these 2 shaded tails together. So we would take 5% and divide by 2, and that would give me 0.025 or 2.5% remaining for this tail right here. What if our values are not exactly within 1, 2, or 3 standard deviations of the mean? Then we can't use the empirical rule and we'll have to use a calculator or RStudio or other software. Probabilities like this can be found a number of ways, one of which we'll explore in the next section in more detail. If we're using RStudio or R, the probability of x less than some value can be found with the command pnorm, where we put our x value and our given mean and our given standard deviation. Note that in R or RStudio, it only works with the less than probability. So if we're trying to find a greater than, we'll need the complement and have to subtract our answer from 1. Now these are continuous distributions, so this is the same thing as the probability that x is less than or equal to some value. With the calculator, the command is normal CDF. We enter a lower limit, an upper limit, the mean, and the standard deviation. If we're going between 2 values, this lower and upper limit would be those 2 values. If we're strictly less than, we use just a very small number like negative 10 to the 6th. If we're doing a greater than, we input our lower limit and then a large number like positive 10 to the 6th. So let's do an example where we have some that are not exactly 1, 2, or 3 standard deviations from the mean. We're going to refer back to number 1. Remember, this was a normal distribution with a mean of 60 and a standard deviation of 10. What's the probability that someone will take less than 45 minutes to complete the test? Using the calculator, we're going to go to normal CDF, so we're going to hit second and variables key, which gives us distributions. Normal CDF is the second one. Now we're doing a less than, so our lower limit is a very small number. It's got a default of negative 1 times 10 to the 99th power, so very small. Our upper limit is 45. Our mean is 60, and our standard deviation is 10. If we're using a TI-83, we'd have to enter these numbers ourselves, and you can use anything like a negative 1 million in this place, or even negative 1,000 would be fine, as long as we're more than 3 standard deviations away from the mean in the negative direction, we're going to be good. And this is our probability, 0.0668, etc. Or 6.68%. What's the probability that someone would take more than 30 minutes to complete the test? Well, back to our calculator, we're going to go back to normal CDF. Now our lower limit is our 30. And our upper limit needs to be a large number, same mean and standard deviation, and it will look like that. And our probability is 0.99865, or 0.9987 when I round it. Last, what's the probability that it will take between 30 and 45 minutes to complete the test? So now our lower limit is the 30, our upper limit is the 45. .065457, etc. Now, if I'm going to use RStudio, the first probability, the probability that x is less than 45, we're just going to enter pnorm 45, 60, 10. The second probability was a greater than instead of a less than, so we have to do the complement. 1 minus pnorm 30, 60, 10. And for our last command, for the in-between, we have to subtract our two probabilities. The probability of the high one minus the probability of the low one. Now, let's say that we know a probability and we want to figure out the x value such that that probability that we are less than that would be true. In the TI calculator, we'll use the inverse norm command. We input the probability, the mean, and the standard deviation. Now again, this is strictly for a less than. If I'm in RStudio, the command is qnorm, probability, mean, and standard deviation. So from example 1, I want to know how long it would take to finish the test if they're in the top 10%. Now in the top 10% would look like this on my curve. This probability right here would be 0.1. That leaves 90% less than our value that we're trying to find. So I'm trying to find the value of little x such that we are less than that, gives us a probability of 90%. So on the calculator, I'm going to go to inverse norm, which is again under our distribution menu. And my area is 90%, my mean is 60, and my standard deviation is 10. 72.82. Using RStudio, I would do qnorm 0.9, then my 60 and my 10.